Good evening, JC.
Hi, Tierra. How are you?
Good. I see it's getting dark there. We're just starting our day here in California. It's bright and early in the morning. And welcome to everyone who has joined us from near and far. And thank you for spending the next hour with us, learning about how we use veterinary medicine and science to keep gorillas healthy and in the wild where they belong.
Hi, Tierra. Hi, everyone. We are from Wera Doctors headquarters in Musanze, Rwanda. It's already 6 p.m. and the evening is upon us.
I'm so excited to get started on this tour I just wanted to cover a couple things with the audience first. If you have a question, please use the Q&A function in our Zoom webinar here, and we will have an answer period at the end of our time here together. And please be sure to include your name and where you're joining us from so we can give you a little shout out when we answer your question. I'll start by introducing myself. My name is Dr. Tiara Smiley Evans. I'm Gorilla Doctor's Chief Veterinary and Scientific Officer, and I'm joining you today from the One Health Institute Laboratory at the University of California, Davis School of Veterinary Medicine, and this is home to our US-based offices. And JC is joining us from the Gorilla Doctors Michael Cranfield Regional One Health Laboratory in Rwanda. And this laboratory's grand opening was actually just in January, so you're pretty lucky today. This is our first sneak peek inside for the public to see what we've been up to the last several months. This laboratory is a regional wildlife laboratory, and it's dedicated to serving our gorilla patients, but also all of the other wildlife that share habitat with gorillas. And it's a regional lab, so it works. We process samples and we work on cases in Uganda, Rwanda, and the DR Congo. And it's important to mention that this laboratory is named after our former director, Dr. Michael Cranfield, who really spearheaded our scientific program and dedicated his life to gorilla conservation. So we're honored to be able to dedicate this laboratory to him. So we're excited to show you what's inside. Why don't you introduce yourself, JC, and we'll kick off the tour.
Sure. Thanks, Tiara, once again. Thank you, everyone who is joining us. My name is Dr. Jean-Claude Tumshime. I'm a laboratory scientist at Gorilla Doctors. I'm here with Dr. Concorde, who is one of our veterinary interns. He's managing the camera for us. So we are very much excited to show you around what we do in this lab. It is going to be an exciting tour. I hope you will enjoy. And I am welcoming everyone to join me in this. Come on, follow me, and you go inside and see what we do in this beautiful lab of ours.
Thanks, JC. I'm excited too. So we had our grand opening in January, but ever since then, our team there has been adding new pieces of equipment and setting up new aspects of the lab every day. So I learned something new that they're working on pretty much every time I visit. So I'm excited to see this also.
Yeah, thanks once again. I'm already inside the lab. As you can see, I have so many pictures of gorillas. It's a beautiful lab, and I'm sure you are going to enjoy this. So allow me to put on my lab coat because it's a best practice that we have to follow when we enter the lab. So I'm going to wear this lab coat so that when I'm moving around, I'll be respecting the rules of the lab. My camera holder also has just put on her lab coat, and we are going to show you what we do inside this lab. So maybe you can come closer. So in this particular section of the lab where we are standing now, it's called a sample reception area. So when our field veterinarians go to visit gorillas and check their health, they bring samples. And when they bring samples here, we process them. So what we do, we take a portion.
Oh, I think the audience here is getting a real life window into some of the challenges that we face every day working across multiple country borders. As I mentioned, we work in Uganda, Rwanda, and DR Congo, and we have a team based here in the US. And part of that involves a lot of Zoom calls, sometimes in which the internet goes out. So we'll have you bear with us as we try to continue through with this. Oh, you're back. Thanks, Jean-Claude.
So I'm by the door of the biobank. So I'm going to give you just a quick snapshot of what is inside this biobank so that we can go inside afterwards and you can see. So The biobank here is only accessed by authorized personnel. So it's got some warning signs. One of them reads authorized personnel only. So that shows that no one, it is not accessible by everyone. It's only for people who have the authorization to do so. Why? Because it stores precious samples for us. So, and also want to tell you that inside this lab, we've got several freezers, and it is a bit loud inside. You will bear with us for that, but I'll try to raise my voice so that you can hear what I'm talking about. And also we have air conditioner inside. So I'm going to take you inside so that you can be able to see what is done inside. So as you can see, we've got several freezers. We also have the air conditioner, and in this lab, I'm going to show you how the lab is physically organized. Then Tierra will talk about how samples are recorded electronically. So in order to do so, I'm going to put on gloves because I want to show you inside the freezer. Then you can be able to see how we store samples. These freezers are called ultra-low temperature freezers or deep freezers, simply because they are minus 80 or 70 degrees Celsius. So as you can see, it is very, very cold inside. And I'm going to show you how those samples are stored, and the temperature, the low temperature function is to make sure that samples are kept for a long time without losing the quality of samples. Maybe Concord can come closer. So this is one of our freezer, which is minus 80. So I'm going to show you how samples are kept. As you can see, I think you are able to see this. So these are called racks, which are metallic holders. In each rack, we have what we call boxes. So as you can see, I'm closing the freezer so that you don't lose the temperature. So in these cryo boxes, and we have 10 of these, we have what we call cryo tubes. The cryo tubes look like this. So this is where we store our samples. So in these cryo tubes, let me put them back so that we don't lose the temperature. I'm going to put them in this freezer. Yes, I was telling you that this freezer can accommodate 32 racks, and each rack has 10 boxes, and in each box contains 81 samples. So we have a large biobank of samples. We have thousands of samples that are kept here, and some of them were even collected way back in early 2000. So they are very precious to us, and we make sure, because we think that these are precious to the scientific community, also make sure that we have a backup freezer like this one that also has racks and boxes and everything that is needed for sample storage. Why? Because in case this gets a malfunction or gets broken, we immediately switch samples and put them in this backup freezer. So I want also to talk about the types of samples we have in this freezer. So we mainly collect fecal material because we collect non-invasive samples. We don't want to disturb gorillas. That's why the big chunk of our samples is composed of fecal material. but we will also collect blood, swabs, especially when there is intervention where we immobilize the gorilla and then we can collect those samples for future analysis. And we can also collect food leftovers. When the gorilla feeds on something, we can pick the remaining food and we can be able to analyze it. I will try to explain that when we reach the analysis section of this lab. So in the interest of time, let me allow Dr. Tierra to explain to you how we record these samples electronically and how we use them. Thank you so much.
Thanks, JC. That was a really excellent explanation of what we do in that particular biobank room. I would just like to mention that this is really just a fraction of our total samples. Gorilla Doctors has curated the largest biological specimen data set for any free-living great ape species in the world. And so we have biobanks like this in all the countries in which we work, and also a small one in the United States. And a really important aspect of that is making sure that we have everything electronically cataloged so that we can find and know exactly what specimens we have and exactly how much volume is left in each one of those tubes, so we know how precious they are and how to prioritize where to put samples towards certain aspects of our research. So we've partnered with a software company called Open Specimen, and they've actually designed a tailored software system for us that allows us to know exactly where every specimen is, and so we can make those important decisions. So the biobank is a really important part of our laboratory and a really important part of our science program because it allows us to treat our clinical cases in real time, but it also allows us to go back in time. So if we have a question about how trends in health or trends in diseases have happened over the past maybe 20 or 30 years, we can go back and ask those questions by going into our biobank and pulling out some of those more historical samples. So where are we at now, JC? Which room are we in now?
Thanks, Tierra. We are already in the hematology and pathology room. We just found one of our interns doing EPG. Hi, patients.
Hi, Ron.
Looks like you are doing an EPG.
Yeah, sure.
Yeah, patients is doing what we call egg per gram. So he's trying to quantify gastrointestinal parasites from the gorilla samples we collected today. So she's doing a wonderful job here. So, and this is useful to us because we want to know what is going on in the GIT system of these animals. Thank you.
Hi, patients. Yeah, so the egg counts are just a part of what we use to diagnose gastrointestinal parasite cases in the gorillas. It's one of the tools we use. And in addition, we use clinical observations. So we can simply observe gorillas and look for signs such as hair loss or browning of the hair coat or sometimes weight loss. And that can clue us in that there may be a potential parasite issue going on. And depending on the severity of the clinical case, we can also perform additional diagnostics to determine the exact parasite that's causing the infection and tailor our treatment course accordingly based on those results. So the parasite room we do a lot of work there, and it's an important part of how we treat our gorilla cases. So where are we at now, JC?
Yeah, we are now in the molecular lab, what so many people call PCR labs. I'm sure so many people know this because of the COVID pandemic that happened a few years ago. So this is the same lab or the similar lab people were using to test COVID. So we have it here, and this is where we are now.
Ah, okay. Yeah, before we walk in that area, I think it's important to note that respiratory disease is the second leading cause of death in mountain gorillas. And that's really not surprising given that our close genetic similarity with gorillas, we are susceptible to the same pathogens that they are. So respiratory cases are really important for the work we do. And this molecular part of the lab is where we do most of the testing for our respiratory cases.
Yeah, you are right, Tierra. In fact, this year in January, we were able to use this lab to detect the pathogens that were behind a respiratory outbreak that happened in one of our gorilla groups called Amahoro. So within 24 hours, when our field veterinarians, actually it was Dr. Gaspar, who brought those samples, were able to pinpoint the viruses that were behind this outbreak, and that helped a lot in the management of the outbreak. So
yeah, that was a really important test of our laboratory, I think, because that was one of the first times we were able to have a sample from the field carried to the lab and have results within 24 hours. And I'd just like to emphasize what a game changer that is for gorilla doctors. So in the past, whenever we had a question like that, we had to collect the sample, package it up for shipping, send it to a faraway lab, sometimes to this lab here at UC Davis, and that took a lot of time. So we weren't able to get results in that sort of short critical period of time that we needed. So having this lab here in Rwanda, right at the base of the forest, has had a huge impact on the ways we're able to diagnose and treat gorillas and keep them healthy and in the wild.
Yeah, that's right. So allow me to explain to you the setup of this lab and several sections of the lab so that you can have an idea how things operate here. So where we are now, it's called extraction room. First of all, the molecular lab has 3 sections or 3 rooms. We have what we call extraction room, where we separate the genetic material from the sample. And then we also have what we call the clean or master mix room, which is basically a room where we mix our reagents and chemicals that we'll be using to mix with samples for further analysis. And also we have the post-PCR room or the amplification room, where we try to multiply the genetic material we have. But for the interest of time, we are only going to talk about the extraction room, and then we'll also talk about the amplification room. So for the amplification room, as you can see, there's this particular equipment. It's actually central to this room. It's called the biosafety cabinet, which is class 2. So it's a kind of containment system whereby you manipulate samples from inside. So the idea here is to protect the operator from contaminating samples or any other external contamination that can contaminate the samples we are testing. So everything is done from this hood. And what we call genetic material here that is extracted from a sample is, for example, the DNA or the RNA. So we get a single copy from this, which will amplify later so that we can be able to detect the pathogen we are interested in.
Thanks, JC.
So,
maybe it would be helpful to explain to our audience here kind of the importance of why we have to separate these different functions of the PCR process into different rooms. Because for people who are into molecular diagnostics on the call here, that's a pretty important aspect of what we do.
Yeah, thanks, Tiara. That's a very, very important question. The lab here has got several doors. So we try to separate what you call the pre-PCR from the post-PCR. Why? Because in the pre-PCR, we only have a single copy of the genetic material. And then when we go to the other side of the room, we have millions and millions of copies of genetic material. And since PCR is a very sensitive test, we want to make sure that there is no cross-contamination. So in other words, there's what we call amplicons. In other words, they are copies of DNA. We don't want them to jump from the post-PCR or the amplification room and come back in the extraction room where everything starts from, and then contaminate samples we have here. That's why we've got several layers of barriers that we use in this molecular setup.
Well, while we're in this section of the laboratory, the molecular section, I'd like to see if I can pull in and say hello to Dr. Alex here at the One Health Institute lab. Hey, Dr. Alex. Dr. Alex is one of our senior research associates here at the One Health Institute laboratory. And Alex is our liaison between the UC Davis lab and the laboratory there in Rwanda. So he spends a lot of time on early morning Zoom calls with JC, late night for JC, going over the day's diagnostics, going over the screen that JC is going to show you right now in that amplification room. And he's also been hugely instrumental for us in getting a lot of this equipment set up and making sure it's functioning at the top-notch standards at the same that we do here at UC Davis. So thanks, and say hi to our group.
Hi, Jean-Claude. Hi, everyone. Good to see you.
Hi, Alex.
How were the run from yesterday?
Come again?
How were the run from yesterday?
Yeah, I think nothing unusual, just normal findings. Yeah, we have time to talk about it next week in the lab meeting we shall have.
Yes, good. Yeah, I'll see you on the next Zoom call then.
Thank you so much.
Thank you.
Thanks, Alex. So what are you showing us here? What's that screen mean?
That's an important question. So today we are testing gorilla samples, and we used what we call real-time PCR. So we can be able to, it's a technique whereby you use this particular machine that you are seeing here. It's called the PCR machine. So we are trying to analyze samples to see whether whether they have pathogens or not. So the technique we use here, and I want to emphasize on this because it was a game changer for our diagnostic capacity. It's called the multiplex PCR, whereby you use one sample, or within one sample, you can detect more than 36 pathogens. So Dr. Thierry and Alex developed this because we wanted to make sure that we don't miss anything that can cause gorilla disease to be sick. So that multiplex PCR uses, or we detect mostly the respiratory pathogens, but we also test gastrointestinal parasites or bacteria or viruses. So because of this technique we are using, we are able, the virus we talked about earlier were detected because we used this kind of technique, which was not there before. So that's what I was trying to show you with this equipment and these figures you saw.
Thanks, JC. And yeah, one of the exciting parts of what we've been doing in the lab so far is trying to diagnose the exact cause of every respiratory outbreak we've seen recently, but also going back in time and trying to diagnose all of the outbreaks that have happened as long as we've been collecting samples. So we're well underway in being able to actually determine which pathogens are the most severe and the most important for the gorillas. And that will allow us to understand how intensively we need to treat cases and to manage our treatment protocol more appropriately. So we're really excited about that aspect of research that is really occurring in that room right there. That's where all of the data is being generated.
Yeah, thanks, Thierry. In addition to that, we also have this small but effective equipment. It's a sequencing machine that we have actually started using. This allows us to identify a pathogen at species level. So it's called the nanopore, Oxford nanopore. So it's very, very useful and robust for us to pinpoint any pathogens we think that is affecting gorillas. So thanks, Alex, for training us out on how to use this. And thanks Tierra and the team for bringing this new technology in this lab.
Yeah, big impact from a very small piece of equipment. I love that. So where are we headed next? Is this, I see this is the end of the long corridor. Do you have another surprise to show us next?
Yeah, we still have another building that we want to show you. Just follow me. And it's an amazing building.
So this is part one of our new science series. And so on our next episodes, we'll show you some of the other rooms in the lab. So we have rooms that focus on bacteria and also rooms that focus on serology or antibody detection that we'll show you next time. Oh, it looks like we have another internet pause. So our headquartered laboratories is based at our main offices location in Musanze, Rwanda. So we have, as you can see, a little clip of the screen there. We have our offices there where our veterinarians are based. This is where when they come back from the field, where they are actually writing up their clinical reports and doing all of their notes from the day. And they're right there outside of the lab, so we can have discussions back and forth quite easily, which is really nice when we have a new breaking piece of information from the lab that they can just walk over and share with the veterinarians right away. I see we have you back, Jean-Claude. Great.
Yeah. Sorry for the small interruption. We are already outside the lab. So, hi, Shadrach.
Hi, Jason.
So, Shadrach is our administrator. I just found him here. So, hi.
Hi, how are you?
Thank you.
Good.
Hi, Gaspard.
Hi, Jason.
Yeah, so Gaspard,
Hi, everyone.
I hope we can see him. Gaspard is from the field now. He has gone to check on gorillas. How are gorillas?
Yeah, a good report from the field. We are monitoring a few cases, but nothing serious.
Oh, that's
At the
wonderful.
moment.
Thanks. Keep it up.
Thanks, Jesse.
Okay, thank you. So we are going to the other building we talked about. Already there. So we are already in the the pharmacy, where we keep our drugs and supplies for treating gorillas. Hey, can you hear me?
Yep, we can hear you well.
Yes. I was saying that this is our pharmacy where we keep all our medicines for gorillas and supplies we use for field. So the person who sits here is not around, is Dr. Method, but there's no problem. He has gone home. So where we are going now is the parasitology room, the histopathology room. That's the important building I was talking about. So it's important because it started running, I think, last month. Hi, Noeli.
Hey, Jesse, what's up?
Good. They're still working.
Are you gonna go ahead?
We are on the call.
Okay.
So
What's up?
I know
say hi to Tierra and
Hey. Well, this is me, by the way. So,
it's Dr. Noel.
yeah.
So Dr. Noel is our regional pathologist. He's running some samples, I see.
Yeah, just finished streaming my case. I'm gonna roll it now to this machine. So, yeah, how's your day?
Not bad.
So, pathology is a branch of medicine that focuses on studying and diagnosing diseases. So, this small room is basically, you said the last month, yeah?
Yeah.
This room is basically where we do tissue processing in a way of doing histopathology. So pathology has can be clinical pathology or anatomic pathology or forensic pathology. So here it's more histopathology. That means we look at the damage disease can do at the cell level, and this helps us understand cause of death of a gorilla. And then that helps us strategize for the next clinical management. If there's any case that looks similar, it helps us prepare and do a clinical intervention that reflects the real case. So yeah, thank you and nice meeting you.
So Dr. Noel, maybe if you allow, maybe you can show our viewers some of the important equipment we have here.
Well, I think the most key piece is this machine. I call it, well, every machine is very critical to have, but this processor, it's called tissue processor. This is the most critical, the centerpiece, and interestingly, like the car key is a piece that helps run this machine. So
without that, you mean without that you can't?
If you don't have this magnet, you're done. I'll close and go home. So
it's so tiny.
That means that I finished my course now. So I go on program. I won't have my samples tomorrow. So I will set. I have about 16 stations down here. Station is it's alcohol and xylene based solution that will be popping up and it's coming in here. I can show you here. I'll put my lock in here. Then when I close, I will do. It's station 1 is 1 hour. Then I'll go to station 16. Then all I'm gonna do, I will just click start. When I start, the machine knows when it ends. So when you come tomorrow morning, my tissue will be ready, and then it will be ready for embedding. Embedding is when you add on paraffin. It's not up yet now, but this is embedding station means you have hot station at 62 degrees, and then you have a cold station.
Looks like we have another short internet interruption. I just want to say how exciting it is to see all of this equipment set up and in place in the laboratory there. I would say of all of the lab setup, I think the histopathology was perhaps the most challenging because of the weight and the size of those pieces of equipment, all of which had to be sourced from the United States or from Europe, shipped on large. Oh, maybe we have them back.
So that means that I'll put it back here. Then I fill in with full of paraffin wax.
Okay.
As soon as I put it here, it becomes dry.
Okay.
So when it's fully dry, I will, well, there's an extra paraffin that would be here. Then I will cut it off and cut it off. Let's have it uniform. And then after super dry, I will take the cassette off, which will have the paraffin and then a tissue. Like pretty much like this. I don't have a sample here. Yeah, like that. See, this one I'm gonna have tomorrow. So this is this is like a lymph node, but this is a lymph node. So when I have this, that's where the real process starts. So I come down here to this microphone. As the name microphone.
One moment, Laura, I think we might have paused for a minute there. If you want to kind of start over at the beginning from your explanation of the embedding so our audience can hear the whole process. I think we lost you from the internet for just a moment there.
All right, yeah, I was saying that embedding station has 2 stations. There's one that is hot at least 62 degrees Celsius, and then there's the one that's cold -5. So once I have my tissue, I just put it in here. I put a little bit of paraffin wax, then I put it in here, I position it the way I want to be cut when I get to the microphone. So, but after that, I cover with, I was telling JC that we've got identification numbers. Every case has a number. So then I will put it back on, fill up with more paraffin wax, and then I'll put it a little bit here, like 20 minutes on the cold plate, which means we'll cool down the paraffin. The paraffin will dry, will become harder. Then easy to, this is the metal, the mold is a metal. It's easy to take my plastic cassette with the paraffin, which will look more like this. This is what the final product will look like. So I was telling you that these are 2 lymph nodes. So then it means I told you that this is where the process. So I go to the microphone. So Yeah. Okay, all right. So we have the microton is all about, I have 5 microns. So I'll be moving this cutting. So when you cut, it's like
Slicing a blade.
it's well, yeah, you make like the whole chain, and then you're looking for the good cut.
Okay.
So because it's not just one cut. You feel like you're done. No, you do multiple cuts, and then you see the one that is looking fairly reflecting the sample.
Mhm.
Then we have about 40-degree water here.
Mhm.
More like iron in the shop. It's just, well, my door is always closed. I don't know how you guys got in here. So then I'll carry this cut into here. We'll spend a few minutes,
Mhm.
and then whatever claps, whatever you see was abnormal will look like soft and smooth.
Okay.
So when it's smooth, I take a slide, like normal glass slide like in the hospital.
Mhm.
Then I scoop it.
Okay.
So when I scoop it, well, when I say scoop, you feel like it's an easy drawing. No, it's not. So you scoop it and you dry it here for a while, and then you put it in the oven for like an hour.
Okay.
Then after this, you do the staining. That's the staining station there. We have 2 stations. One is we do only the basic, which is hematoxylin and eosin. Then you will have something after the staining. You have something like this, right?
Okay.
That's how it looks like. So then you put a microscope, and then you see the pretty much like this. Can they see this image?
Yeah, they can, I think.
That's an image you can see. This is the skin, and this is how the skin. A micron cut of the skin will look like on the microscope. So sometimes we are so much confused of a case that we don't know, we're not familiar with.
Mhm.
Then I have a microscope with a camera that I consult doing the Rensi and Davis that can tell me, oh no, well, this is that, or this is that. So I do as well. Yeah, that's in a summary, that's what we do here. So thank you for your visit, and nice meeting everyone on the audience.
Thanks, Noel. That was so wonderful.
Thank you.
Tiara, anything
Well,
want to ask Noel?
yeah, this was wonderful to see you, Noel, in your element, in your own lab.
My little room, right?
I must say we miss you here at UC Davis. So Dr. Noel spent almost a year here at UC Davis training with pathologists, and also at Johns Hopkins University training with pathologists there. And he's just now returning because we have this new laboratory that he can work in right at the base of the forest. So we miss you here, but really excited to see you back there doing your work right where the gorillas are, which is such a game changer for us.
I miss there too, especially professors and residents that we've had a chance to work with, and people at Primate Center, people at Marine Mammal Center. So everyone who helped and everyone who keep helping to make this laboratory be a reference in the whole East Africa. So we serve 3 countries. So our goal is to have this lab serve the gorillas and other wildlife. So we appreciate all people who have contributed to make where we are. I mean, it's just we don't in January, but I feel like it's been a year already. So. Thanks so much.
Thanks, Dr.
Thank you,
Noel.
Noel. Yeah, thanks so much, Noel. Yeah.
Well, thank you, JC and Concord, I think behind the camera there, for this wonderful tour and sneak peek into the daily operation. Oh, hi, Concord.
Can look at you guys.
Excellent
Thank you so
video.
much, Concord. This was so wonderful.
This was an excellent tour. And before we start answering some of the questions from our audience, I just want to say from my perspective, what a dream it has been to have this lab here in the location that it is, right where the gorillas are. When I first joined Gorilla Doctors about 1.5 years ago, our first major task together as a team was to come up with our science strategic plan and really identify the key scientific questions that we need to answer over the next 5-10 years that will help us keep gorillas healthy and in the wild where they belong. And when we looked through all those questions we had come up with, every one of them really required us to have this laboratory right here in Rwanda to serve the region and to be able to answer questions more quickly. So this is really a dream come true for all of us. Even in just the short time that we've been open, we've been able to start to understand some really important aspects of respiratory cases and what the actual causes are of individual outbreaks. As Dr. Noel is starting to get up and running with his laboratory there for histopathology, we're being able to diagnose causes of death much quicker than we were before, which helps us inform in real time how we treat cases. So I've just been completely amazed in just this short time what we've been able to learn. And I can only imagine what we're going to learn in the coming years. So thanks for taking this little bit of time with us today to peek into our lab. And I think we are getting close to the top of the hour here, and we can start to take some questions from the audience. Does that sound good to you, JC?
Sure. Thank you so much. Thank you, listeners and viewers. I think this is time for you to ask questions, and then we can try to answer your questions. Thank you so much for joining us.
Okay, great. Well, I think I will start with the first question. This is from Ed, who is joining us from Phoenix. And the question is, what are the most common diseases found from the mountain gorillas that we are finding in the laboratory? And are they different in Rwanda, Uganda, and DRC? So I think I'll turn that over to you, JC, particularly for the respiratory viruses. And maybe you can share some of the specific viruses we've detected so far using our multiplex assays.
Thanks, Tierra. Like you earlier said, most of diseases that affect gorillas are respiratory pathogens. And to be specific here, since we started using this lab, we are able to detect, we were able to detect rhinoviruses and para-influenza viruses. And those were found like in the Virunga Massif where we operate. So those are the major findings so far, and a couple of bacteria, Staphylococcus and Streptococcus, and we're still investigating on those cases. Thank you.
Yeah, and I think that's an important point to mention, that some of those viruses don't cause necessarily severe disease in people. Rhinovirus causes the common cold in people, but it's a good reminder that it can cause more severe disease in gorillas. So it's always something we're on the lookout. And just because it's simple in us, in humans, it might be a little bit more complicated in a gorilla. See, the next question we have is a comment. This is from Bridget. And the comment says, thank you for the highly interesting insight into One Health research on site. I had the opportunity to attend a presentation by the Helmholtz Institute for One Health's Ecology and Development of Zoonoses Research Group at the, I'm not going to pronounce that correctly, members meeting last week. In my view, this interdisciplinary approach is a game changer for the protection of gorillas too. Thank you, Bridget, for that comment. That's a really nice insight. I think one of the underlying aspects of our work that's really important for gorilla doctors is embracing the concept of One Health. So we know that we can't just treat gorilla cases in a silo. We have to make sure we're taking into account that gorillas live in an environment where they're interacting with people, they're interacting with other wildlife species, sometimes they're even interacting with domestic animals. So because of that, gorilla doctors, and this laboratory in particular, takes on research projects that involve not only gorillas, but also other wildlife that they share habitat with, and sometimes domestic animals too. Because we know if we don't have healthy human populations and healthy wildlife populations surrounding the gorillas, it makes it really hard for us to have healthy gorillas. So thank you for that comment. Let's see, the next question here. This is Marcy from Dallas. How many staff do you have working at this facility? I think I'll turn that over to you, JC, to explain our whole staff group here for the lab and in Rwanda in particular.
Okay, thank you much for the question. Let me first answer for the lab part. We are so far 3 scientists who work in this lab, but every time we work with our interns, so they come on rotation basis. Every year we recruit 2 interns, and then we train those interns in what we do. Then for the field, I think we have 3 veterinarians in Rwanda who attend to gorilla cases whenever there is a report. They also do regular monitoring of gorillas to check on their health. So we also got some administrators and data entry personnel who work on that. And that is Team Rwanda only. We also have staff in Uganda and DRC. Thank you.
Yeah, and I'd like to call out our internship program too, because I think that's been a really valuable way for us to connect with the universities in Rwanda, and also for us to kind of test out potential new hires. We've been able to find a lot of our excellent veterinarians and staff through the internship program. So it's been a great thing, and we learn a lot from them as well, because they're fresh out of school and they are coming with the newest ideas and the newest techniques that they're learning at their university. So that's a program we want to continue and expand well into the future at this lab.
Yes, that's right. Because most of us, I think all of us were the products of internship. So it is very crucial to us to work with universities and, pick the best of the best from the universities.
Yeah, we get fabulous interns. Okay, the next question is for JC, and then this is from Rob in San Francisco. Oh, this is an important question. Do you have backup for the -80 refrigerators and freezers in the event of electricity power outages?
Yes. First, when we established this lab, we are careful about that because we also want to maintain the cold chains of what we do, and even when we are running samples. So we have backup generator that caters for the whole headquarters, but we also have backup freezers that we use for store. In case there is a broken freezer, we can easily switch those samples to a new or an alternative freezer. So we have backups, and we have also what we call the UPS, and uninterrupted power systems, so that when you are running a test, you don't lose the test you are running. And because running the lab can be very expensive, and you don't want to lose either reagents and samples that are precious. So we have backups. Yes.
Yeah, that's a very good question. And that was one of the very first important safety mechanisms we had to think through when designing the laboratory, because power outages are very common where we work. And we know that those biospecimens are critically important to us, as well as the individual samples that we're using and we're working on in real time in a PCR machine. So we have backups for the PCR machines while they're running, and then also for our big freezers. Okay, our next question is from Heather. And the question is there a history of certain diseases in the last 10 years compared to 20 years ago? That's a really interesting question, and I think something we're going to hopefully be having lots of scientific papers coming out in the coming months as we're starting to answer a lot of those questions. I would say one of the things we have noticed a big change in the past 10 years compared to maybe 20 years ago has been parasite cases. So we've noticed an increase in the number of gorillas that have gastrointestinal or stomach-related conditions that we think are associated with higher numbers of parasites or different numbers of parasites. And that's actually a collaboration we've been working on with the Czech Academy of Sciences for the last several years to investigate what could be maybe the environmental drivers of those changes. Is this something that climate change is potentially impacting the types of parasite species that are in the gorillas? Are there changes in the plant species that the gorillas would normally eat that help keep parasite loads down? So we're really investigating that question in particular right now, because there has been such a change from maybe 20 years ago to 10 years ago. Let's see, our next question. This is Tony and DK from Memphis, Tennessee. How many gorillas in total do you follow in the countries there? Also, how often do you hospitalize gorillas in your new facility? So I should clarify that Gorilla Doctors works on habituated gorillas. So the distinction between that is some of the population is completely wild and we can't get very close to them. But a large proportion of the population, I think about 73% now across all of the countries, are habituated to humans. So we can come close to their group, we can observe them, and those are the gorillas that Gorilla Doctors follows intensively. And then how often do you hospitalize gorillas? This is a really important distinction to clarify for our work because our hospital is actually the forest. So we never take a gorilla out of their natural habitat to do all of our work. Everything we do is based on our teams trekking into the forest with all of the equipment that we would need to do an intervention, to do a darting. And they do everything that they need to do right there in the forest, often with the rest of the group present. So our hospitalization policy is a forest policy. All right, next question. This is Todd from Los Angeles. Congratulations. Gorillas so far. Is Giardia a problem there? That's a very good question. Currently, one of the two species that we're most concerned about, and this is really recent information that we've gained through our collaborations with the Czech Academy of Sciences, but we're looking at cases of esophagostomum and Mershidea that are causing the most severe clinical cases in the gorillas at the moment. So that's what we're watching very carefully. Okay, next question is from Joe in Washington, and this question is for JC. And it says, first, thank you for the work that you do and for the session. How are the gorilla families acclimated to your team who are in the field to obtain samples? Does it vary between mountain and growers gorillas? I'll turn that one to you, JC.
Sorry, I had some internet issue. Can you repeat the question, please?
Sure. The question is, how do the gorilla families acclimate to our teams when we need to go collect samples? And is there a difference between mountain and growers gorillas and how they respond to our staff?
Yes, thank you. I will start from how these gorillas maybe are habituated to us and how we collect samples from them. So I told you earlier that we mainly focus on non-invasive sampling, whereby we collect samples of fecal material from animals without necessarily disturbing a gorilla. So to be specific, when there is, for example, an active respiratory outbreak or gastrointestinal problems, we collect fresh samples from gorillas. Just we follow gorillas and then we can pick fresh pieces. But also there are situations where we collect samples from gorilla night nests. Then we can be able to analyze them. And another part is when there is clinical intervention where we immobilize gorilla. But to be specific, in Rwanda, we have mountain gorillas and they are habituated. We can easily collect samples from them without touching them. And even for growers, they are habituated. The team from DRC, they are also able to collect feces and other samples from gorillas. So just know that our priority when we collect samples, we do non-invasive sampling. I don't know if I answered you correctly.
That was an excellent answer, JC. Thank you. And I think an important point to make for our lab is that the majority of the samples we're working on are non-invasive samples. So it didn't require any disruption of the gorilla's regular day to collect them. And that's an aspect of the research we do that's really important for us, is constantly trying to come up with the best techniques and find the best diagnostics out there that can work on very small volumes of sample that we can collect, because our goal is always to be as minimally invasive as possible and be able to collect as much information as we can from what we can find around the gorillas in their environment. Well, I think we are almost at the top of the hour here, and I just wanted to say thank you to our audience for those really excellent questions. I think we covered a lot of topics here. And thank you so much for spending this hour with us. We hope this is the first of many that you'll join us on, as we can start to share more and more pieces of what we do in the lab and what Gorilla Doctors does with our science and plans for medicine in the forest. So thank you, everyone, and see you next time. Take care, everyone.
Bye.
Thanks, JC.
Thank you, Tiara.